So our goal today is to talk about matrices, okay? But we're going to start by doing what we'll call warm-up problems, but really they're just problems off worksheet 5 that I just didn't have time for yesterday. So the first one I want to do is number 2 on worksheet 5. We can write this as a system a couple different ways. It says Sky Meadow Gardening carries 2 brands of fertilizer containing nitrogen and water. They have Gently Green, which is 5% nitrogen, and Sun Saver, which is 15% nitrogen. So we are to combine these in order to make 90, hang on, my cursor's not friendly yet, 90 liters of a solution that's 12% nitrogen, okay? We could set this up with a table, or we could just set this up as a system. What are the 2 things we need to know? Okay, so in the end, it's how much of each of these that we're going to use, right? So amount of Gently Green, which is actually liters of solution, and liters of Sun Saver. All right. In the past, when you had these in a math class anyway, you might have done a little table like this. Ugh, that was bad drawing, sorry. Try that again. So you had the Gently Green, the Sun Saver, and the mixture. And then you did something like this. You said there was X of this and a total of 90. So maybe you put 90 minus X here. Does that sound familiar to anybody? If you wanted 90 liters, okay. And then in here you would want your percents. So you did 0.05 and 0.15, and the mix you want is 0.12. And then over here we wrote an expression like 0.05x, 0.15, 90 minus x, and then 90 times 0.12 or 0.12 times 90. And then you took these 2 and you added them together to equal this. Now, we could have set it up as a system since that's the section we're really in. The total of the 2 that you mix together has to be 90 liters. Does that equation make sense? Okay, which really is what this is. Because if you add these together, it's just we used only one variable in my little chart over here. Then the percent from the Gently Green was 5%. The percent of nitrogen you get from the Sun Saver was 15%. And the percent you want of the total is 12%. So these are the 2 equations for our system. But if we use substitution and made y equal to 90 minus x, we're going to get the same thing we did over here. Okay, Ben, go ahead. I'm just saying you could solve it as 2 variables or 1 variable. Here I just used 1 because I said if the total has to be 90 and one of them is x, the 90 minus x would be the rest. Okay, which is the same as using 2 variables and then doing substitution. So the equation we're going to have since I'm out of room, can anybody do 90 times 0.12 for me? Thanks. That came from there. All right, I'm not going to take time to solve. Any questions? Kind of, sort of. Use that as a model for, I think you have to do one of the percent problems on the back of this worksheet. It's assigned for homework, okay? Number 2, just a quick overview, or 3, this is, I'm sorry, Vermont Railways freight train leaves Boston heading to Washington, D.C. at a speed of 60 kilometers per hour, so there's a rate. 2 hours later, okay, so now we're at time, something to do with time, leaves Boston bound for D.C. on a parallel track at a different rate. How far from Boston will the Amtrak catch up with the Vermont Railway train? All right, so one leaves and then another one leaves, and we want them to catch up with each other at some point. Now the distance is equal to what? How do you find distance, guys? What formula do you use in science for distance? Distance equals? Okay. So what do we know about the first train, its rate? The first train, yes, it's 60 kilometers per hour. And the second train leaves, and he's going faster. He's going 90 kilometers per hour, which is the only reason he's going to catch up to the first train, right? Now, who gets a head start? The first train or the second train? The first train leaves first. The second train leaves 2 hours later. So the easiest way to solve this, even though they want distance in the end, is to find the time. It's a confusing question. All right, so we're going to let t be time. Do you want to put t and t plus 2 or t and t minus 2? Anybody care? Doesn't matter. 2 hours later, so you want to do t minus 2 for the second one? Does that make sense to you? Okay, so I'm going to do time is t here, and this guy, it said leaves 2 hours later. Okay, so the expression for the first one is just 60t. The expression for the second one is 90 times the quantity t minus 2. Now that's expression for distance. If they catch up to each other, what do you know about that distance? Yes, it equals. So if I solve this real fast, I get t as 6 hours. So the first train was on the path for 6 hours before the second train caught up, because we put the t in the first train. But it actually asks how far from Boston. So we need a distance. What can we do? Yeah, we just need to plug it back in, right? This train was going 60 kilometers per hour for 6 hours. So that's 360 kilometers down the path, the rail. If we had plugged it in the second one, we should get the same answer, right? So the answer is how far from Boston? It's 360 kilometers is the distance they're looking for. I don't think there's one like that on the quiz, but there might be one assigned on 5B. All right, last warm up, just because this is what we did yesterday. Remember we talked about the current? This is very much a current question, but it's a wind question. So the plane is flying along and the wind is either helping it or hurting it. Does everybody understand what we're saying? Just like the current yesterday? Okay, so a Boeing 747-400 jet flies 4 hours west with a 60-mile-an-hour tailwind. Returning against the same wind takes 5 hours. Find the speed of the plane with no wind. So if you wanted to think of it as a little chart, we have there, going there, which is with the wind. And then there's coming back, and that's against the wind. Now, what do you know about that total distance? If you're going there and back, it's the same, right? So if I do some kind of rate time distance here in my little chart, can you fill something in for me? What about the times? There is 4, back is 5. Okay. So as it was going there, the plane was flying some rate, but what was this wind doing? Because it's a tailwind. It was helping it, so this is just plus 60 because we actually know how fast the wind is going in this question. And what was the wind doing on the way back? Working against it, so it's minus 60. Now, we don't know the actual distance, but we know they're equal, so what could we put here? Well, I would just do 4r plus 60 and 5r minus 60, and then what are we going to do with those? Yeah, these are equal distances, so we'd have 4 times r plus 60 equals 5 times r minus 60. And then you'd solve and find the speed of the plane. That's it. Anybody get 540 miles an hour? Okay. So those are the kinds of questions that you could possibly see. We'll spend some more time focusing on the one that might be the kind that are on the quiz. All right. So that was warm up and finishing talking about review of systems. All right. On worksheet 6, we're going to talk about matrices and all the different operations you can do on matrices, okay? I found a couple slides today just to very quickly talk about why matrices, what they do, okay? In the real world, they use matrices for cryptography, in other words, to encode and decode, whether it's messages or, you know, things transmitted on the internet, whatever. It's also cable industries, the cable TV, where people who are not customers, okay, so encoding things on to keep, you know, you from watching Netflix without a Netflix account, that kind of thing. All right, in economics, I thought this was interesting. It's used to calculate gross domestic product. Didn't we just have a question about that the other day? Computer animations, I thought was one you guys might be interested in. So all that gaming stuff, they use matrices to take a figure and transform it across the page, okay, to make it bigger, smaller, reflect it, rotate it, etc. And it says also useful for anything to do with engineering, architecture, okay. Basically, anytime you have more than one unknown value, you can use a matrix to solve. So we're going to use it to solve systems of 3 equations and 3 variables shortly. But today we're just going to talk about what you can do with a matrix. So a matrix is just an organized set of numbers. So it could represent, you know, here, let me show you one later. I should put this towards the top here. So this is a word problem from a book that said a furniture restorer who's refinishing chairs, tables, and dressers, the amount of time for each step, and the cost per hour. So this is he organized, when he does a chair, it takes him a half hour to refinish it, 2.5 hours to sand it, and an hour for the putting the varnish on or whatever. Okay? When he does a table, a dresser, Okay? Another thing you could do is if you had, you know, you're doing the inventory at your store, okay? You have size 6, size 8, size 10, you have t-shirts, sweatshirts, pants, whatever, you know. You could have inventory of any kind because it's just in a little, basically kind of a little spreadsheet there. All right. So when you have this, you need to be able to identify the dimensions of that matrix. The dimensions are the number of rows and the number of columns. Now, it's really important that you know the rows come first. Rows go across, okay? These are rows. These are columns. Just like on the front of a house, a big old house can have columns or pillars, okay? They go up and down. So this has 2 rows and 3 columns. Everybody good? 2 by 3. It's rows by columns. This is really old. They talk about RC cola. Just some of you know what RC cola is? Okay. Okay. Because most people don't even, that's not one of the big ones anymore, but it's cheap. Yes. All right. So once you know the size of the matrix, the rows by columns, so tell me rows and columns here. This is all in one row, but it has what? 2 columns. Same as this one. What about this over here? 2 rows by 3 columns. Okay? It says you can only add or subtract if the dimensions are the same. So if both of these have the same size, then we're allowed to add them. It's like, guys, you have $6, your sister has -2. Okay? The following week, your sister makes, or you make 3 and your sister makes 1. Now how much do you have altogether, each of you? 6 plus 3 is 9. -2 plus 1 is -1. Do you see how easy this is? Adding matrices you can handle. Okay, subtracting, you have to be a little careful because there's negatives here, but these are the same size. So we could subtract them. You know, a reason to subtract would be if you had an inventory of supplies and then you sold a bunch of stuff, you want to know what's remaining in your inventory. It doesn't make a very good question here because these have negatives, but you take this one minus this one, and what are you going to get? Be careful. -1 minus -6 would be plus positive, so you'd end up with 5. Because it's -1 minus -6, okay? 2 minus -5 would be 7. -4 minus 3 would be -7. -4 minus -2 would be -2. -3 minus 6 would be -9, and 1 minus 4 would be -3. That's kind of miserable because of all the negatives. That's it. Yep. Okay. That's how you add and subtract matrices. All there is to it. And there is a question on the quiz, and there is a question on the final. It's an application, though. It says, here's the inventory of your store. Okay. You get a delivery to the store of this. So what's your new inventory? All you're going to do is add them together. Easy peasy. All right. So this is question 3, algebraic. Can we do this or not? Be careful. 1, 2, 3. This is all 1. 1, 2, 3. Because you see it's all in one space here. So this is 1 row by 3 columns. And so is this one. I'm going to go through this really fast because I'm not going to ask you one like this. You'd have 4zx minus 2y. Anybody tell me what the next one would be? A -3x and then minus the quantity y plus 5. I'm not even bothered to distribute it. And then the last one, x minus 5y minus -1 or plus 1. I should just skip that one altogether because I'm not going to ask you one like that. What about number 4? What size is this guy? 2 by 3, and this is a 1 by 4. Can you add those? No, you can only add when they have the same dimensions, okay? So you could just say not possible. I'm just writing down why it's not possible. Everybody good? All right. This is what's called a scalar. You will have to do a scalar application question on the quiz and on the final. A scalar is when you multiply everything in there by something. Let me just give you a super quick example of what's on the quiz. If I said I'm going to charge $1 for red candy, $2 for blue, and $3 for the purple candy because everybody wants the purple candy, okay? And then I say, I decide, wait a minute, I'm going to increase this price by 10% for everybody. So you would take and multiply this scalar by 1.1, 110%. Does that make sense to everybody? So then the answer, it's just going to multiply everything in there by that quantity. So you'd end up with 1.1, 2.2, and 3.3. So the new price would be $1.10 for red and whatever I said a minute ago. Okay? So that's how you use a scalar. So all this is doing, can anybody tell me what this is going to become? Okay? So it doesn't change the size, it just multiplies everything in there. Now, we could do this first step. We could multiply this, and it would be negative 10 and 5. Whoops, don't put a comma there. That's okay. But when we go to subtract, can we do that? They're not the same size. This would be a 1 by 2, and this would be a 4 by 1. Again, I just want you to make sure you're comfortable with the dimensions, but you cannot do this. Not possible. All right. Any more of those? This is just a little silliness, but can you figure out what matrix Y looks like before they multiplied it all by negative 3? So negative 3 times something gave them this. So we just undo it. We'd get what? 1, no, negative 1, negative 4, 7, and 7. So we're just dividing. I'm not going to ask you that on a quiz, but what about this one? This would be a pretty good question. I don't know that it's on the quiz, but what did they add that it became this? 1 plus what is 5? 0 plus what is negative 3? 6 plus what is 7? Okay? All right, then we get to matrix multiplication. Matrix multiplication is tricky. Okay? In order to be able to multiply matrices, and you have to know this, what has to be true is that the number of columns in the first one has to equal the number of rows in the second one. So you can multiply we'll say 1 by 2 can be multiplied by a 2 by 5, we'll say. Okay? These must match up. These numbers have to be equal. The size of your answer will be based on this. You would get a 1 by 5. One more time. If you are talking about rows of the first matrix by columns of the first matrix, and then rows of the second matrix by columns of the second matrix, these must be equal. And your answer matrix will be this size. Okay? So that's, can you do it and what size will it be? So before I try to do this, I want to show you this application. Remember we talked about chairs, we could finish them, take off the old finish, sand them, and put the new finish on. We could do that to tables, we could do that to a dresser. What size is this matrix right here? 3 by 3. Okay, the cost per hour to do those 3 things, to take it off, sand it, and refinish it is listed here. What size is this matrix? Which is it? 3 rows across, all in one column, right? All right, now, this is important. What does this 3 represent? The first one, the number of rows. It was like the kind of the furniture, right? And this was the hours. What does this 3 represent? Well, okay, hours per project, okay, hours per step of the project. And this is also the steps, right? And this one, what was the label up here? Cost. If we multiply these together, because we can, they have this number the same, we will get a 3 by 1. What will the 2 labels be on that 3 by 1? Can you tell? The kind by the cost. So if we take half an hour of finishing, look what's going to happen. We're going to multiply this row by this column. This should make a little bit of sense to you. Half hour of finishing, the cost for finishing is 7. 2.5 hours of sanding, the cost for sanding is 18. 1 hour of finishing, the cost of finishing is 10. So each element gets multiplied by this number, and then to find the total cost, we'd add them all up. So what we're doing is taking the numbers in this row, multiplying each one separately by these in this column, and then adding them together. It's complicated, okay? So to do this one, you would do 1 times 7 plus 2 times 9 plus 3 times 11. Remember how I said you always do row first? It's row times column, row times column. So help me finish this. That was 1 times 7 plus 2 times 9 plus 3 times 11. They got 58. Okay, get your calculator. All right, for the next one, this entry right here, I'm doing this row times this column. So what would I type? 1 times 8, good job, plus 2 times 10, plus 3 times 12, which gives me what? Okay, everybody get that? Okay, so down in this spot right down here, I'm in the second row, so I'm using the second row, and I'm in the first column, so I'm using the first column. So now I'm typing what? 4 times 7 plus 5 times 9 plus 6 times 11. 130. Okay. Anybody think they get this? Tell me the last one over here. We're in the second row, second column. So now we're doing what? 4 times 8 plus 5 times 10 plus 6 times 12. What'd you get? Anybody else get that? Okay. All right. Good job. So let's go here. First of all, what size is this? 2 rows across, right? By 3 columns this way. Okay. Just making sure we got that. Times, they want to know, can you multiply it? How many rows across is this? 3, but it's all in one column. Can you do that? Well, the rule is these have to be the same. Are these the same? Okay. And the answer will be a, okay? Answer will be a 2 by 1. All right. So I want you to draw a great big 2 by 1 here. 2 rows, but all in one column. So there's 2 rows all in one column. So now we're going to fill in how we're going to get those numbers. And I want you to write down the work so you remember how you did this. Kelsey, you awake back there? Okay. So row 1 by column 1 goes in this spot. Can you write down what we're typing? What are we typing? 0 times negative 4 plus 2 times 0 plus, I should have made mine bigger. Plus what? Negative 4 times 5. Which all boils down to what? Negative 20, yeah, because we multiplied the first two by zeros. Okay, now I'm moving down second row by that same column again. So it's 4 times negative 4 plus negative 4 times 0 plus 6 times 5. 24? No? $14 is right. Right? Because it's negative 16 plus 30. That's not 24. That's my bad. All right. Now, I'm going to show you how to do this on the calculator eventually, but I'm also going to tell you that on the quiz, I'm going to throw a letter in there so that you can't use calculator. So let's look at number, is this what your number 10 says? It's a B. Okay, this is the letter B. So can you do this one? 2 by 2 times a 2 by 2. Yes, you can do it and you'll get a 2 by 2. Okay, I'm going to make a really big 2 by 2 though because I want to do the work. So when you go back and look at this, you remember how you did it. All right, I'm going to use a little color coding for your benefit. Row 1 times column 1 goes in row 1, column 1. So what am I doing there? 6 times negative 3 plus negative 5 times B, which would be negative 18 minus 5B. It's going to have a B there. You can't do anything with it. This is a B. Purposefully so you can't use your calculator, okay? Then I'm going to show you how to use your calculator. But you can't use your calculator on the quiz for one like this. All right. Now, I'm still using, if I want to do this one next, what am I doing, guys? If I want to do this spot next, I'm doing row 1 times column 2. So 6 times negative 6 plus negative 5 times negative 5 would be negative 36 plus 25, negative 11. All right, how do I get this guy down here? Row 2, column 1 again. So 1 times negative 3 plus 3 times B would be what? Plus 3B. Okay. And last but not least, to get row 2, column 2, we have to do row 2 times column 2. So it's 1 times negative 6 plus 3 times negative 5, which is negative 6 plus negative 15. I think you get negative 21. Is there another one with a letter? All right. What size are these? This is a 3 by 2. Be very careful. And this is a 1 by 2. Can you do those? Okay. What size is this guy? 3 by 2. Be careful. 2 by 1. So can you do this one? Okay. What size is your answer going to be? A 3 by 1. So 3 going across this way, all in one giant column. Can I just not do this one because I'm not going to ask you one that tricky?
Yeah.
But the point is, on the quiz there is a question that just says, can you multiply these and what sides would the answer be? So did we cover that right now? Okay. So I'm just going to leave that. All right. Let's do one on the calculator. Want to do that? So let's see. Do we have? Maybe I have one on one of these slides. You know what? Let's do this question right up here. I'll make it bigger though for you so you can see it. So, what size is this first one? 2 by 2. And what size is this second one? 2 by 3. So can you multiply these? And you will get 2 by 3. All right. So we're going to put this in matrix A on our calculator, and we're going to put this in matrix B, and then we're going to multiply them. All right. So on your calculator, do you see where it says matrix, anybody?
Yeah.
It is here. Okay, it's under the math button, the one below it. So we're going to do second and then that button. And to enter a matrix, you have to go to edit. So we're going to arrow to the right twice. And the first one I want to do is matrix A. Now you could have something in here, but we want to put in our new one, which was a 2 by 2. So I'm just going to type 2, enter 2. Okay, second, and then the button below math, arrow to the right twice to get to edit. And we're doing A, and we said it wants to be a 2 by 2. Now it's going to give me 4 spots to type numbers in. Does that seem okay? So now I got to reduce this so you can actually see. And let's put A in there. So 4, it does go across. So then -2, -1, enter, and 3. So one more time, you might want to write the steps down. It was second, and then this guy to get to matrix. And then we had to go to edit. So we went to the right twice. Okay, and then we had to tell it the size. And then we entered our terms in there. Okay. Now, you just quit. When you're done, you got them in there, you just go second, mode, quit. Now we want to go in and put in matrix B. So how do we do this? Second, and then the inverse button, I'm going to call it, arrow to the right. Very carefully, you got to go down so that you're in B. Otherwise, you're going to put it right over the top of the one you just did. And what size is this one going to be? 2, enter 3. Okay, so after I hit enter here, I have now a setup to put this in. Okay. And I got to make it so you can see the numbers. There you go. -1, 2, 3, -2, 4, and -1. Okay. Everybody good? Then you're going to quit again and just go back to the home screen. Now on the home screen, what we want to do is just put the name of A times the name of B. So we're going to go second, matrix button or inverse here, and hit enter because we just want the name of A. And then times second, that button down to B, enter. Now, let me ask you this question. Can I do B times A?
No.
Why? Why can't I do B times A? Yes, because the size would be different, right? What did I do? Because it would be a 2 by 3 times a 2 by 2, which is not allowed. Okay, and it says dimension mismatch, the size of the list doesn't work, okay? All right, so did you write your answer down? Or you guys don't even have this one? Okay, we'll just move on. But everybody saw how it displayed it on the screen. Did I even show that? It displayed it nicely as a matrix here, right? The right size and everything. Okay. Last thing I'm going to talk about really quick is a determinant of a 2x2. This is a weird concept that we're not going to spend a lot of time on because the calculator does it for us. But it's real easy when you have a 2x2. You multiply this diagonal. How weird is that? So you get -6, and then it's minus this diagonal, which was what? -10. So we'd end up with, is that 4? And what would you get for this one? -6 minus 12, which would be -18. Determinant. Oh, what does yours have? So this is -12a. Okay, so then you can't do anything with it. All right, but determinants are used to solve systems, but our calculator will do them for us, so there's not determinants on the quiz. Same with inverses at the bottom, okay? You guys have a section of inverses, yes? Not on the quiz, so we're not even going to talk about them today. So these are the questions you need to do on worksheet 7. Does anybody have worksheet 7 out? Can someone look at 7 real fast? 18 or 19, those aren't inverse questions, are they? Worksheet 7? 19 is? But 18 is a determinant or something? Okay, so you can cross off 19. This should be the shortest homework assignment ever. But what is the one thing if you don't do, you're never going to remember how to do on the quiz? No, what's the one thing we did today that was tricky? Yeah, the rows times column multiplying thing. Okay, so practice the multiplying, especially the one with a letter in it. I'm guessing, is it 9? Anybody have it out still? The one where you multiply, does it say, is multiplying 7, 9, 14? Which one is a multiplication one? Anyway, one of those in the middle there is a multiplication.